When working out the demand for dwelling feeders, the National Electrical Code, specifically Section 422.13 in the 2005 edition, states that fixed water heaters less than 120 gallons shall be considered a continuous load. This means that when calculating the load for the feeder, the water heater component must be taken at 125%. This 125% factor is applied because continuous loads are defined as loads where the maximum current is expected to continue for 3 hours or more. To properly size the feeder, you must account for this increased demand. This is crucial for preventing overheating and ensuring safe operation of the electrical system. The question arises whether the 40% derating factor of 220.82 can be applied to this 125% value of the water heater load. According to the code, the feeder must be rated for the full 125% of the water heater's nameplate rating. The 40% derating factor outlined in section 220.82 does not apply to the water heater component when determining the minimum feeder size. The 40% derating factor in 220.82 is applied to the general calculated load of a dwelling unit after the application of the 125% continuous load. Let's illustrate this concept with an example. Suppose you have a water heater with a nameplate rating of 4,500 watts at 240 volts. To calculate the load for the feeder, you need to determine the current draw of the water heater. This can be calculated using the formula amps equals watts divided by volts. In this case, it is 4,500 watts divided by 240 volts, which equals 18.75 amps. Since the water heater is considered a continuous load, you must multiply this current by 125%. This gives you 18.75 amps multiplied by 1.25, which equals 23,4375 amps. This is the minimum amperage that the feeder supplying the water heater must be rated to handle. Now consider a dwelling unit with a general calculated load of, for example, 100 amps after applying the 125% factor to any continuous loads, like the water heater. If section 220.82 applies, you can then apply the 40% derating factor to the general load. This derating factor would only apply to the portion of the load that meets the requirements of section 220.82 and would not affect the already calculated 125% load of the water heater. To clarify, section 220.82 provides an optional method for calculating feeder and service loads for dwelling units. It allows for a demand factor to be applied to the general loads of the dwelling unit based on certain conditions. However, this demand factor does not override the requirement to rate the feeder for 125% of the continuous water heater load. The purpose of the 125% rule is to ensure that the wiring and overcurrent protection devices are adequately sized to handle the sustained current draw of the water heater. This prevents overheating, potential fires, and premature equipment failure. When sizing the feeder, you must select conductors and overcurrent protection devices, such as circuit breakers or fuses, that are rated to carry at least 23,375 amps in our previous example. It's also essential to consider other factors such as voltage drop and ambient temperature when selecting the appropriate wire size. Using a wire size that is too small can lead to excessive voltage drop, which can affect the performance of the water heater and other appliances. Additionally, high ambient temperatures can reduce the current carrying capacity of the conductors, so it is crucial to adjust the wire size accordingly based on the temperature rating of the conductors and the ambient temperature conditions. In summary, when calculating the feeder load for a water heater in a dwelling unit, remember the following steps. Firstly, determine the nameplate rating of the water heater in watts. Secondly, calculate the current draw of the water heater by dividing the wattage by the voltage. Thirdly, multiply the current draw by 125% to account for the continuous load requirement. Fourthly, ensure that the feeder conductors and overcurrent protection devices are rated to handle at least this calculated current. Fifthly, consider other factors such as voltage drop and ambient temperature when selecting the appropriate wire size. Remember, the 40% derating factor of 220.82 does not apply to the water heater component. The feeder must be rated for the full 125% of the water heater's nameplate rating. By following these guidelines, you can ensure that the electrical system is properly sized and installed, providing safe and reliable operation of the water heater and other appliances in the dwelling unit. It's always advisable to consult the latest edition of the National Electrical Code and local electrical codes for specific requirements and interpretations. Additionally, it is essential to consult with a qualified electrician for any electrical work to ensure compliance with all applicable codes and regulations. The consequences of not properly sizing electrical feeders and adhering to the National Electrical Code (NEC) can be significant. Undersized feeders can lead to overheating of conductors, insulation breakdown, and even electrical fires. Overcurrent protection devices, such as circuit breakers, may trip frequently due to the overloaded circuit, causing inconvenience and potential damage to equipment. In addition, undersized wiring can result in voltage drop, which can negatively impact the performance of appliances and equipment. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the resistance of the conductors. This can cause appliances to operate inefficiently, overheat, and fail prematurely. For example, a water heater operating with a significant voltage drop may take longer to heat water, consume more energy, and have a shorter lifespan. Furthermore, improper electrical installations can create safety hazards for occupants. Exposed wiring, loose connections, and damaged equipment can increase the risk of electric shock and electrocution. It is crucial to ensure that all electrical work is performed by qualified electricians who are familiar with the National Electrical Code and local electrical codes. Regular inspections and maintenance of the electrical system can help identify and address potential problems before they become serious safety hazards. These inspections should include checking for loose connections, damaged wiring, and properly functioning overcurrent protection devices. In addition to safety considerations, compliance with the National Electrical Code and local electrical codes is essential for legal reasons. Electrical installations that do not meet code requirements may be subject to fines, penalties, and legal action. Insurance companies may also deny coverage for damages caused by non-compliant electrical work. Therefore, it is crucial to ensure that all electrical installations are performed by qualified professionals who are familiar with the latest codes and regulations. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and industry best practices. Local electrical codes may also have additional requirements that are specific to the jurisdiction. It is important to consult both the National Electrical Code and local electrical codes when planning and performing electrical work. In summary, properly sizing electrical feeders and adhering to the National Electrical Code are essential for safety, performance, and legal compliance. Undersized wiring can lead to overheating, voltage drop, and potential fires. Non-compliant installations may be subject to fines, penalties, and legal action. It is crucial to ensure that all electrical work is performed by qualified electricians who are familiar with the latest codes and regulations. Regular inspections and maintenance of the electrical system can help identify and address potential problems before they become serious safety hazards. By following these guidelines, you can ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. Remember that the 125% rule for continuous loads, such as water heaters, is a critical aspect of electrical safety and should not be overlooked. Consulting with a qualified electrician is always recommended for any electrical work to ensure compliance and safety. Electrical codes and best practices are subject to change. Staying informed about the latest requirements is a responsibility for anyone working with electrical systems.